Tectonic plates. The massive basalt rock sheets on which continents sit are called tectonic plates. These tectonic plates also support oceanic mountain ridges that soothe not only the planet Earth, but accounts for the passage of cold and warm currents on the seas, giving the westerly winds and climate patterns the influence they shed on land masses. The revolutionary discovery of plate tectonics has led to a challenging of all traditional views that rest on the old notion of a stable planet. The new concept of plate tectonics pictures a turbulent, dynamic world where during 4.6 billion years of geological history, oceans have been buffeted about like hulks on a stormy sea. This revolutionary insight also answers riddles that have baffled man since the dawn of natural sciences. How the continents, oceans, mountains and islands were formed, the reasons for volcanoes and earthquakes, and why marine fossils are found embedded on the Himalayan peaks, to name but a few of such geological enigmas. Scientifically, the discovery of plate tectonics is as significant as the Darwinian evolution or Einstein's laws of energy and motion, and as important to humanity, says Maurice Ewing, Dean of American Oceanographers in the Reader's Digest's The World Around Us. Far from being the solid, indestructible shell once imagined by geologists, the Earth's crust consists of a number of separate plates, actually 10 major ones, subdivided into varying sizes, and these are made of rock 64 to 96 kilometers thick, which float on the hot, viscous mantle beneath them. The Earth's land surfaces, which rest on these plates, as do the ocean floors, were once welded together in a single supercontinent. Some 200 million years ago, this supercontinent began to split up. Eventually, its pieces formed the present 7 continents and the major islands we know now. These land masses have slowly drifted apart like packages on a moving conveyor belt. The crustal plates are being built at their edges by molten rock welling up from deep fissures in mid-ocean. At the same time, these plates are being propelled across the globe by forces arising from deep within the earth in various directions at the geologically wild speeds of from 1.27 centimeters to 15.24 centimeters a year. Phenomenal things occur as the plates jostle one another for room. When a moving continental plate made of mainly granite meets an ocean floor plate consisting of dense, less buoyant basalt, the continent rides over the sea floor plate like a titanic bulldozer. It scrapes off the layers of sediment deposited on the sea floor over many millions of years, as well as slices of crustal rock. This debris piles up along the edge of the continent like a rumpled blanket, forming mountain ranges. The ocean floor plate is forced down at a steep angle into the trenches at the edge of the continent. It melts from the heat of friction, forming deep underground pockets of white-hot lava. The trapped lava is forced up through crevices, erupting on the surface to create volcanoes. The collision, separation and shearing of the crustal plates also cause seismic disturbances.